Today we're going to talk about an introduction into the margin of error. So what is a margin of error? A margin of error is usually a small amount that is allowed for in case of miscalculation or change of circumstances. It's the cushion that's around a statistics and determines how accurate a study is. So have you ever noticed a bottle of soda at the store that seemed to have a little more or a little less soda than the others? Shouldn't it be illegal to sell underfilled soda? Well, industry and manufacturers are allowed a certain amount of tolerance or margin of error in the products they produce. Machines are often efficient but aren't perfect, so sometimes you may get a little more or a little less than the advertised amount, but over multiple purchases you will get what you paid for. Other common places we see margin of errors in political polls. In the example below, if you read the fine print, you see that the survey has a margin of error plus or minus 3.86%. So this is the fine print right here. Therefore, Donald Trump may have a vote as low as 40.14% or a vote as high as 47.86%. And here you can see that they only surveyed 644 people at Elon University and used those votes to predict the results for the entire population. So this was, it says, an Elon poll for president. Who would you vote for? Trump, Clinton, Johnson, or undecided? So that was our margin of error. And again, the 644 is the sample size. So the margin of error is an interval estimate, a pair of percentages surrounding a guess about some attribute of the entire population based on a random sample of the population. It assesses the precision of a survey's estimates. A smaller margin of error suggests that the survey's results will tend to be close to the correct values. Conversely, a large margin of errors indicate that the survey's estimates can be further away from the population values. A parameter is a number describing a whole population, while a statistic is a number describing a sample. The goal of quantitative research is to understand characteristics of populations by finding parameters. So to calculate the margin of error, you need to know the size of the sample. For example, in the election poll, there were 644 people. We represent the sample size by the variable n, and multiplying by 100 converts the result into a percentage. So the plus or minus sign tells the percentage of margin of error should be added to determine the upper range and subtracted to find the lower range. So this is our equation right here that we're going to be using. So the margin of error is equal to plus or minus 1 over the square root of n, where n is the sample size, and then to put it as the percent, we multiply that by 100 to get the percent. So for the next question, it says, find the margin of error for a survey of 100 American teens. So if that means 100 is equal to our n, so in our equation, then the margin of error would be equal to plus or minus 1 over the square root of 100, and that's equal to plus or minus 0.10. So if we times that by 100, we get plus or minus 10%. So then if we look at example number 2, it says compare the margin of error to the compare that margin of error to the margin of error of 900 for the sample size. So the margin of error here would be equal to plus or minus 1 over the square root of 900, which equals plus or minus 0.033 times that by 100 to put it as a percentage. So plus or minus 3.3%. And then find the margin of error for a survey of 9,000 teens. So plus or minus 1 over the square root of 9,000 gives us plus or minus 0.0105 times that by 100. And that gives us plus or minus 1.05%. And the margin of error for a survey of 90,000 teens would be plus or minus 1 over the sample size is now 90,000. That equals plus or minus 0.0033 times that by 100, and we get plus or minus 0.33%. So you can see that as the value of n is increasing, so your sample size, you'll notice that the margin of error is 10%, and then it goes from 10% to 3.3% to 1.05% to plus or minus 0.33%. So that means that as the value of n increases, the margin of error decreases. As the value of n decreases, the margin of error increases. So this kind of starts to get into some stat, which if you go into statistics, you'll do more of this, but it has to do with what we call a confidence interval. Confidence intervals are associated with the confidence level, such as 95%, which tells us the percentage of times the confidence interval actually contains the true population parameter that we're trying to get or we're seeking. So the distance from the estimate to one end of a confidence interval is referred to as the margin of error. So if you want to make a confidence interval smaller, you increase the sample size. So you can see that this would be the confidence interval, and the margin of error would be plus or minus on both sides from the middle. So in this, if you look here, this is saying that, again, if you are increasing the sample size, you will then decrease the margin of error based upon your sample size. So that's why, of course, it's always better to get a larger sample of the population. So let's go ahead and look at some examples. So we want to find the margin of error given a sample size of 25, and we're around to the nearest 10th. So the margin of error is equal to plus or minus 1 over the square root of 25. And then, of course, we're going to multiply that by 100 to put it as a percent. So that gives us plus or minus 20%. Find the margin of error given the sample size of 360. So the margin of error, sometimes people just write ME, which is fine too, is equal to plus or minus 1 over the square root of 360 times that by 100, which gives us plus or minus 5.3%. The next question says, a survey shows that 36% of citizens support a tax rate increase. They survey polled 450 people. We want to calculate the margin of error and then list the lower and upper range of the results. So the margin of error is plus or minus 1 over the sample size, which is 450 people. And we're going to multiply that by 100. Which gives us plus or minus 4.7%. And then we want to find the upper and lower range. So the lower range, it says a survey shows that 36% of citizens support the tax rate increase. So then with our margin of error, the lower range would be the 36% minus 4.7%, which gives us 31.3%. And the upper range would be 36% plus the margin of error 4.7%. So 40.7% would be the upper range. The next one says a newspaper releases statistics about a recent poll about the Senate election. It says that between 40% and 50% of those surveyed said they would vote for the Democratic candidate. Upon reading the fine print, you discovered they surveyed 30 people. Is the newspaper telling the truth? Explain your conclusion and use math to support your reasoning. So it says for the first part, so if the range is 40 to 50%, we're going to begin by finding the mean percent to determine the base statistics. So to find the mean, we're going to add these together, divide them by 2. So 40 plus the 50 divided by 2 gives us 45%. Then we're going to use the sample to determine the margin of error associated with the survey. So for the margin of error, we know that the sample size, it says, was 30 people. So we have plus or minus 1 over the square root of 30 times that by 100. And we get plus or minus 18.3%. And then we want to find the upper and lower range using our mean to help us. So the next part would be the lower range. Would take the 45% and subtract the margin of error. So if we subtract 18.3%, we get 26.7%. And then the upper range, we take the mean and add the margin of error, which gives us 63.3%. So the question says, upon reading the fine print, you discovered they surveyed 30 people. Is the newspaper telling the truth? Explain your conclusion and use math and reasoning. And so again, it said that the newspaper released statistics about the poll and saying that between 40 and 50% of those surveyed said they would vote for the Democratic candidate. So that means, based upon our average of those two, that the newspaper is lying. So they should have said between 26.7% and 63.6 or 63.3% of citizens plan to vote for the Democratic Party. Again, and that's because of the margin of error. Question 5 says, now, given the margin of error of plus or minus 3%, we want to find the sample size. So again, we know that the margin of error is equal to plus or minus 1 over the square root of n, and we're multiplying that by 100 when we have the percent. So if we have plus or minus 3%, that is equal to plus or minus 1 over the square root of n times 100. The first thing you would do is divide both sides by 100 to put the 3% as a decimal. So when we put the 3% as a decimal, divide that by 100, we get plus or minus 0.03 is equal to plus or minus 1 over the square root of n. And of course, we don't like the square root of n in denominator, so you can cross multiply or just multiply both sides by the square root of n. So we get plus or minus 0.03 times the square root of n is equal to plus or minus 1. And we're solving for the square root of n, so we're going to divide now both sides by the 0.03. So we get the square root of n equals plus or minus 0.03. And then we want to square both sides to get rid of the square root. Sorry, I didn't mean to put n, square both sides, so 2. And so when we square both sides, we get n is equal to, and remember when you square, negative becomes a positive, so the plus or minus is essentially goes away. So we have 1,111.1. And again, so let's just take a look at this in our calculator. So just to show you, 3 divided by 100 is where we got the 0.03. And then we had 1 divided by 0.03, which gives us oh, did I write it? Sorry, I didn't realize. I wrote that again here, so this should have been 1 over, sorry about that, 1 over 0.03. And so we're squaring that. So 1 divided by 0.03 squared, again, this gives us this value here. But since if we're talking about people or samples, we usually don't have part of a sample. So normally we round up for this. So I would say 1,112 samples for the sample size, depending on what it is we're talking about. So then same thing for the next one. So for the margin of error of plus or minus 5%, finding the sample size, we would do the same thing. So we have the margin of error equals plus or minus 1 over the square root of n times 100. So plus or minus 5 equals this percent plus or minus 1 over the square root of n times 100. So we're going to divide by 100 first. And if you do that, we get 0.05 plus or minus 0.05 equals plus or minus 1 over the square root of n. So plus or minus 0.05 times the square root of n equals plus or minus 1. So the square root of n equals plus or minus 1 over 0.05 or 0.05, same thing. And then we're going to get rid of that square root by squaring both sides. So n is equal to 1 divided by 0.05 quantity squared, which gives us 400 for our sample size. And that is it for our margin of error notes.